Cool. Okay, all right. Okay, start. So, okay, it's great to see you all. Thank you for coming here today. And as you can see on the screen, our topic is about reverse engineering and binary exploitation, Intel x86, x86, and 64. And maybe it's a part one. And I guess that's all for our topic. So buckle up, boys and girls. This will be gonna be a fun ride. Okay. So about me, um, I am Fatah. I am Fatah Shim, and wait, try these features. You can. I am Fatah Shim. Sorry. I am Fatah Shim. You guys can call me Fat, and this is my Chinese name, and this is my alias. All right, I am blogging at these links, and can contact me on LinkedIn. And I am focusing more on vulnerabilities and malware in research and development, and reverse engineering, OS internal, application security, and sometimes I do CTF. And I don't do web much, right? And I'm from I'm GCC and MCC alumni. You guys can check it out. The links here. Interesting camp, and yeah, should check it out. And from the right side, all of this. Here's the pictures from my previous talk. If you are there, in the previous talk, thank you for coming to this session again. Disclaimer. The views and opinions expressed in this content are on my own and do not necessarily reflect the views and opinions from any company or organization that I'm affiliated with. So, table of content. There is a lot of materials to cover. We may need to split it up and pick up where we left off and continue for the next class. It must be noted that explanation is not geared towards learning how to program. No prior knowledge is assumed for this course. Just a Windows operating system with 66 and 64-bit Intel processors and interest in software security, reverse engineering, and malware analysis. The goals of this sharing is to provide comprehensive introduction to programming in assembly language, and the reason from this training is more about understanding how a computer works instead of developing a large program. In table of content, we have 46 topics to cover. No worries, it looks a lot, but I promise not too lot, because the method here is that lecture, practical, lecture, practical, lecture, practical. So to make things not boring here, it's not all lectures and in the end the practical. No. And we will learn about why we need to learn assembly, and the curve learning, legal aspects, legal activity, illegal activities, static and dynamic analysis. Practical, we'll set up our environment before doing practical. Introduction about assembly, some basics that should know, binary stuff, heads, and we'll learn about this, low level, high level, interpreted language. We learn about compiling also, disassembly, and decompiler. And this is an overview on debugger that we will dive into and learn a lot from it. And prologue, epilogue, we'll look it up later. Holdout, we will do it also later. And Trojan detection on the program, data storage size, registers, lower portion, partial register, instruction. This is interesting part and crucial also to know. All right. And method. This method also we showcase later. Drop a code cave, And EIP, the most important register also. And important flags, Indian, segment register, calling convention, memory hierarchy, architectures, CPU, RAM, and the stack, crucial to know. NASM, Linux, and user space and kernel space, and the resource for further learning. This is all the topic that we will cover in this lessons, right? So why we need to learn about assembly? The typical question always asked by student is that this is the answer. So you can become a better programmer when you want to get the most of your processes writing in raw assembly is needed. Tool is just a tool. Having foundation in your brain is a way of survive. Because when you know about fundamental, the foundation, the basic, you can, if there is a new tools, any tools, you can just take not a lot of time to learn it. And yeah, having a foundation is crucial to know other tools, to test, to experiment other tools. All right. You're a kind of person who really likes to know how things works. In this course, you'll get solid understanding on how programs works from the inside. All right. And you want to become a reverse engineer, security research, and read code of viruses or look for software vulnerabilities, as most of the time original source code will not be provided to you. And solid understanding about x86 language is mandatory if you analyze on Windows architectures. And there is a lot of jobs out there to do this work. Not a lot of people want to do the work, right? Because people tend to scare away, sadly, because about reverse and binary exploitation, because it's hard to learn. The truth is in the beginning is always the hardest. Life reward for who work hard on it, and just don't give up on it. All right. So we're done here. This is the curve learning. The curve learning, the comparison between reverse engineering and pen tester. This is just an opinion. And from reverse engineering, it's getting hard in the early, because you need to learn assembly, when API, internal, a lot of things really takes time, but it is only in the early state. But after you master everything in the foundation, you are good to go to learn new things like ARM or things that make things easy lah from here after that. Different from pen tester. This is just my opinion, because maybe it's easy and tools everywhere provided. You need not to have to learn internal or really deep in processes or architecture. But yeah, this is just my opinion here. The curve learning, right? So we'll be focusing more on towards this legal aspects. From legal aspects, before that, shout out to Tuan Hafiz for this information. Thank you. Reverse engineering, legality, government, copyright laws. So depends on government copyright laws, and different country will have different copyright laws. Legal is legal only in specific cases. So yeah, this one for aspects. This one for activity. For activity, legal things that we can do is the recovery our lost source code, recovery of data from legacy formats, malware analysis and research, and yeah, for research also for security and vulnerabilities. Illegal activities, this one bad guy. I mean, don't do that if you don't want to end up in jail. Okay. reverse engineering competing products and sell it. Okay. Crack copy protection. That's bad. Distribute crack registers for copyright software. This one never download distributed crack or something crack, because if the potential high risk on the crack is that there is malware on there, and yeah, stages or a lot of dropper on there, so be careful on that. And gain unauthorized access to any computers. This is bad, so never do that. This is illegal activities. So we come to static analysis. So what is static analysis? That it's just abstract identifying features and other characteristics from the tools without actually extracting features and other characteristics from the tools without actually executing it. All right. We will read some of them is read the assembly code, search for strings, analyzing without executing the program. Yes, it's a static analysis, and yeah, basically just a strings formation. So here's is a couple of those. You can see example of the static analysis. So for example, number one is object dump in Linux. And this is utility designed for full metadata analysis and reporting tool for executable files. And file, I believe there is a lot of people using it. File, this one built around Magic, which is a library that can perform metadata analysis also. And yeah, you can the slot information can be see here, like you know, the format, what bit, what architecture, and is it a strip or not. And strings, one of people use this utility scan to files from beginning to end and attempt to discover strings encoded and yeah, human readable characters, to put it simple. And the end, in the end is HashDump. HashDump is some display or filter on specific files that can be output all these text. You can analyze it from here. Okay. Dynamic analysis. On dynamic analysis is that you're executing the program. So debug the code, step through the code, study how it execute and what it does. Fast result and accurate. Executing code either on your physical and in your physical machine or emulator. Tracing the code that get executed and analyze the code execution. All right. So we come in a practical setup environment. So what you will need is that can either have bare metal, VirtualBox, virtual player, or VMware, or any your hypervisor that you want to use. And we will need this tool also. We need to download this x64 debugger. All right. It can be installed in Windows. I prefer for Windows, download in Windows. And you need also Windows operating system, which is cover 64-bit. And yeah, this is some optional. Okay. All right. Yeah. So let's move this. This is slow. Okay. For practical setup, of course, you need to have hypervisor that I'm using currently is VMware Workstation. So you can download our Windows operating system in the virtual machine. And we will need also debugger. You can go to this link, just type x84 dbg, and it will show something like this in the website. Just click the download, and it will be redirect to the page download, and you can just download the tools. Okay, and yeah, you just Windows and Ubuntu, that's optional. Okay, next. And on, okay, this part, you need to open up your operating system virtual machine. So wait, let's it load. Sorry about that. I just open it up. And oh, it's out. Oh, that's fast. Okay. So what we will gonna do here is that we will go to wait. Row. Okay. We'll go to these tools. Okay, this tool, and we'll go to option, preference, and go to event. And yeah, there's something that we need to set up before we do the practical. All right. So no worries about this first. You can just open the tools. Okay. This is the interface from the tools. Okay. What is it here? First, you can go to option, preference, and events. Preference and event here. So uncheck TLS callback and system breakpoint. So we need to uncheck these two, TLS callbacks and system breakpoint. Okay, we don't need that. And for GUI, you can go just in this tab. GUI graph zoom mode, tick it. Okay, you need it for zoom purposes. And yeah, maybe next there is also have. Okay, next step. Goes to exception. Okay, exception here. And I'm sorry if it's faster. No worries, because it's recorded. You can watch it back and do it again. And exception, you can go to inno range and put add digit. Okay, 1 byte, 2 byte, 3, 4. Okay, a digit 1, 2, 3, 4, 5, 6, 7, 8. Okay, and have here 1, 2, 3, 5, 6, 7, 8. All right. Okay, and is there more? Is there more? Okay, I guess that's good already. Just save it. Next step. Next step is open your Windows OS or virtual machine setting and change your network adapter to host only. Okay, this current most of default is net. So we need this is the best practice is to change to host only, a private network shared with the host. Okay, so yeah, change this to host only. All right, and click OK. And next. Oh, okay. Make sure you take a snapshot, just in case anything unintended happen, you can revert the previous step. So how to snapshot is that you can just click here the plus button. For current, I have already do snapshot. So yeah, this is from previous session. So I'm here now. Okay, just take the snapshot and store it. All right. Next. Or if you're curious to explore more and download the binary for hands-on training, for hands-on testing, the binary. Okay. Can just go to the list to this link. Wait, I drop it in Google Meet. In this chat. Okay. Already submitted. And this is already binary exists that that already being compiled. And if you want to compile it by yourself, if you want to compile it by yourself, you can just use Visual Studio, code block, any GCC, G++, or any WinWinW, any your compiler preference, and yeah, compile it by yourself. That's another option. It is in C program, and here's the source code. Okay, the source code, and oh, sorry. Oh, wait. Oh, all right. Sorry about that. Here's the source code. So can write it and compile it by yourself. But no worries. In this link also, it already have C program, C file, and just look up the scripts. All right. And for the last practical setup environment is that what's the best way to transfer binary if you already download the binary from the links and want to paste it inside your virtual machine is that you can use Python server. This is some example below. Python server, drag drop, and VM share folder. Okay, mine already got here. This is my share folder. And depends on your preference. Yeah, there's a lot of the way to transfer the files to explore it. Okay. Wait a moment. I guess that's all for this half minute, and let's take a break here before we dive in more on assembly main topics. So we already done our first goals to practical setup environment. Okay, so rest about 5 minutes, and 9:16 we will continue. Right? Okay. Let's take a break. Cool. If you guys have any question before 9:16, we can talk about. So no worries. Can talk about. Let's take a break, 5 minutes, something, and chat something. All right. Have any question like out of scope or um, in scope? So I try to answer it. Oh, there's 65 participants here. That's a lot. Thank you for coming today. I hope you guys interested, and yeah, can learn some things here, some things from here. All right. So the session for first part will be end in 9:36. All right, and maybe there is some leftover of the on the topics we learn for the next class. So no worries on that. Right. There is a lot interesting things in the end of session. The showcasing, yeah, practicals and yeah, really fun stuff. Yeah. 2 minutes more. Any question? Okay. Step 1 to 6. No worries about if you want to see the slide again. No worries, because in the end of the session, I will share it the slide, and everyone can access it. So no worries on that. But yeah, I show you that. So practical setup, environment 1, 2, okay, good, 3, 4, 5, and 6. All right. So I want to share it here. I'm gonna check it out. Okay, good, good. Okay. Hope you guys can catch up, but no worries. It's recorded. Okay. Okay, welcome. All right. It's already 9:16. Let's continue our session without waiting more. Okay. And we get back on this. Okay. Rest time already 5 minutes, and let's continue. Introduction to assembly. All right. It's a main point. Assembly language is a low level. Okay. It is a okay. Sorry. This is a low level. Okay. Low level programming language and language, and it provides the basic instruction interface to the computer processors. And assembly language is close to the processors, and you can get as a programmer. And programs written in high language translate into assembly language in order for the processors to execute the program. All right. Assembly language also gives you direct control of the system resource. Okay, you have a lot of control here, right? System resource. That's how you get. I mean, you have power, right? And this involves setting like processor registers, accessing memory location, interfacing with other hardware elements that require significant deeper understanding on how the processors and memory works. Okay, this some brief about assembly. So there is a lot of documentation and source code out there, but it can be difficult to learn without a guide. Okay. Different versions have different processors, and we'll go through all we Intel. Okay, the one I highlight before in the topics, focusing more on Intel processors, and most of it will be covered on 32 bits and 64 bits. Right. The most of top slides we will focusing more is 32-bit, because when you know 32 bits, it will be easier. You want to learn to 64-bit, because current operating system is already most of it already 64-bit. Right. There's also other processors, the other assembly also. SPARC, PowerPC, and MIPS. I believe this is some IoT. So correct me if I'm wrong. This is for Mac and others. All right. You don't need to have everything here memorized before moving on, and parts of it will make sense when you actually see it in action. All right. Okay. And all right, for basic stuff, binary and hex number system. This is some basic foundation that you need to strong on this to understand before going further more on topics. First, you need to know decimal. Most of the time is that we are using these numbers, this format numbers, decimals, this to represent numbers 0, 9, 10, 11, 12, 13, but in decimal format. All right. In binary is that it has 0 and 1, 1 for high voltage and 0 for low voltage. And this most of the topic will be focusing more on hex. So we will focus more on towards this base 16. So easy to differentiate between decimal number and base 16 is that from 0 until 9, okay, and from A to F, we will start from 2 digits, 10, 11, 12, 13, 14, and 15. All right. If it's already 2 digits, it will convert to alphabet here. All right. Okay. Yeah. And next. So that is the way to convert numbers. Windows calculator that make our life easier. So we need not need to calculate it manually, everything. Okay, how do we know about it? How do we want to get to know about this? Is that just from default, you already have calculator in your operating system and your Windows in bare metal, right? Just click the calculator. In default, I believe you guys already have standard calculator. You guys can change it from standard to programmer here, and here the selection. This top is hex format, decimal format, opt, and binary format. So let's prove if this calculator works, right? And let's go back to previous slide. Okay, F in hex is 15. Let's click F on this. Okay, here is the result. And you cannot make it bigger. I'm sorry on that. But you can see the result here. Let's say we put F here, the hex, and the decimal will be 15 as in the slide. All right. Let's close this. Move forward. Okay, you also have a way to convert it easy also, but inside a debugger. All right, inside a debugger, and we already downloaded this before. I asked you to download. I hope you guys download it, and this is tools that you just need to click this tab here, this calculator icon, and this is all format that you can change on it. Not also the sign and unsigned. There is negative and positive value. All right. Sorry on that. Let's open up our debugger tools, SAD2, and go to this tab. Okay, go to this tab, calculator, and yeah, it launch here. And here also the format, we can just read it out, and sign and unsigned will be a decimal format here. So let's say I am putting 15. You see, this decimal format, and the hex will be F. Okay, can put a lot more complex numbers. Let's I put something small, and yeah, you can see the binary, the oct, and hex. Yeah, this is the way to convert it easier. All right, and next. Okay, why we need to convert it inside in debugger? I mean, why we need to use hex? Okay, why we need to play with hex? Why not just use the decimal format in everything? Because here's the answer. Because I need to change it to pen. Because hex best system is saving spaces. All right. As I showed before, calculator, and let's say we put like F before this. You see, the decimal is 2 digits and just need one digit here. So the reason because it's saving spaces, right? Some idea here. This is all hex format. Okay. This alphabet differential. This alphabet you can just see it easy to think is a hex format. And this is 1 byte. Not also that these two digit will be represent for 1 byte. Okay, 1 byte. Okay, 2 digit okay, represent 1 byte. Okay, we'll go a lot here later. No worries, we cover this later. All right. So we come to the low level language. Okay, low level language is a human readable version. Okay, human readable version of the processor instruction set, and we will learn about this this instruction. So no worries, I will cover it in practical, so you guys can get better understanding about it, and without just no theory. No worries. Push to the stack and pop recover it back, and no operation, move something and jump, unconditional jump. Okay, no worries. I will look up in the session, in the next part. Okay. The assembler generates assembly language. Okay, the assembler. There is a lot of tools here. I'll give some recommendation later. The assembler. So it's from. I'll give some explanation later. Okay, let's say you write something. You write something on high level programming, and you compile it. You compile the code into ESC program. It depends ELF anything, and you want to read the source code from this file, but how? The way is with the assembler, so we can read it with assembly program, and this is a lot being used for malware analysis to check the behavior of the program. All right. Next, this is the high level language that can be reliably recovered from malware. Okay, malware when source code is unavailable. All right. Okay, this is some explanation I already gave before. Okay. Okay, high level language. Most computer programmers include who write malware dev. Okay, operate at the high level language. High level language provides strong abstraction from the machine level and make it easy to use programming logic and flow control mechanism. If you do development, the more low is it like C. This is a example here. C, C sharp, C++, C sharp. It already low level, but in our view, is in high level language. But most of the malware to make things like easy to control, the more control on the resources, and they are using this language. Okay, and convert to machine code by a compiler. Okay, in high level language, they want to convert it from high level language. Let's say example .c. You want to make it executable. You need compiler from here. There is a lot of options. You can use code block, Studio, and GCC, plus, and many more. So yeah, help you guys understand it. Interpreted language. Okay, this is current nowadays. People using it in the highest level, and example like Java, C#, Perl, .NET, and Python. It's a top already at a top level. The code, and at this level, is not compiled into machine code. Instead, it is translated into bytecode, right? It is translated into bytecode because bytecode executes within an interpreter, which is a program that translates bytecode into executable machine code on the fly at runtime. For example, like Python, there's a lot of people using it nowadays. And intermediate, and bytecode execute. There's already explained it here. Yeah, example Java virtual machine. Yeah. You guys can look it up in this link, right? And next, compiling. We are here compiling, and I believe I explained this before. So let's explain again to make a better understanding on it. So let's say malware author development here. Their write code and in high level language. Let's say this code like C, C++, C sub depends everything in high level language. They will need to compile it. Yep, can be code block and C++ and GCC. Any compiler, because there are Intel compiler. There is a lot of compiler out there. Can just look it up in Google. And when they compile it, and we'll convert it to machine code. Machine code here, so it's runtime in CPU. So this is the hex format. And the way, like I said before, malware analysis we do is to deassembler it, malware analysis and to the low-level language. This is some example: push EBP, push EBP to the stack. Move ESP to EBP is moving something to the EBP. This is destination and source. Oh yeah, we'll cover it later. All right. Subtraction. ESP 0s40. As malware analysis, you need to better clear understanding about this. Right. Depends on the samples. Right. Okay. Assembly code is the code that actually runs on your computer by the processors. The purpose of language like C is that you can write program without having to really deal with assembly code. Okay. I try to explain again about machine code. It consists of opcode also. Opcode hex digit that tells the processor what you want it to do. It's not just one language called machine code. Just as we speak different language as people, machine speaks different language. Which is the computer language. All right. I have like 3 minutes, 4 minutes. We will end in compiling parts. So let's end in here. Right, compiling also. For compiling process, like I give an example like C. Let's say you have source code like C, C++, some .hash, and this is let's say malware development here, maldev here. They will need compiler to do it. I explained before. And when they it will need they will convert to assembler, and it will need also some dependencies like .o library and something linker, and yeah, you will get executable format from here. There is a lot of different architectures and different type of processors can run different type of assembly code. There's MIPS, ARM, and a lot of processors out there. And yeah, this crash course, it's not full course. We are dealing with the most of 64-bit, 32-bit, ELF and ESE format. ESE, okay, portable executable. All right. Okay, compiling also. What you can see here is that this is tools from NSA, Ghidra. And yeah, we have tools such as Ghidra that will take compile assembly code and give us a view of what it thinks the C code that the code was compiled from those lines. So yeah, we don't need to learn from the assembly. I mean, it will make things easier from here. But please note is that when it from these tools will convert to high level language. Okay, this is a high level language here. You can see here, right? This is low level assembly and stuff. You need to note that when it convert to high level language, sometimes it's not accurate enough. It's better you understand it from the assembly itself, from the low level, right? And oh yeah, this thing, the convert is not always accurate, and it's better to understand it from the assembly itself, right? You need to note also. Okay. All right. There is two options like this. Let's say executable format file, and two options to read the available source code in this program. So that you can read it in low level, and low level is that you can learn it in assembly here. Okay, this is advantage here is that it accurate. Okay, and the next is high level language. Okay, high level language. You can read it from high level language also, thanks to tools like Ghidra and IDA. Okay, this topic is not covered much on IDA, but this is some recommendation if you want to analyze it. in high-level language can go to Ghidra and IDL tools. But take notes also when you decompile, we call it decompile when you decompile to read the source code, and it's better to have understanding both here, right? It's better to understand both here, right? I guess we already in the end of the session, 9:36, and I actually want to continue it, but let's make it part 2 on this. So yeah, let's end for the session part 1 here, and we will continue our session with Q&A, and we'll stop at 9. We'll stop at 9:45, 46 or 7 this night. All right. Yes, that's all for part 1. Right. Oh, sorry for the spoil. You can ask any question here. It's already the end of part 1. Q&A session. Is there any question here from participants? Oh, 72 people. Okay. There's a lot of people here. Thank you for coming for tonight. Learn some stuff. Any question? Do you not use IDA? Just curious. Depends on what tools you want to use. Tools is just tools. If you know the basic, the foundation already, you good already. Yeah. You can use IDA Ghidra. You want to use IDA, just make things easier for understand. You got good features on there. Okay. Should I know resource materials such as website or book you use to learn RE? Could I know your resource? Oh, no worries on that. I will. There is a lot of resource. There is resources documentation that you can look it up in the end of the session. Okay, this is part 1. Sorry on that, I cannot share the resources, but there is the end of the slide. Maybe part 2, part 3. You will know the resources. We will learn what in here first. Okay, right. What is the big differences between reverse engineering and binary exploitation? When you want to know about binary exploitation, it is crucial to know about reverse engineering also, because when they say you want to find the vulnerabilities in the program, you need to reverse it and learn about get understanding about underlying of the programs. And once you know how the programmers by reverse engineering, and you can exploit it for the next stage exploitation phase. No worries on that. For now, is part 1. I mean, this topic is for assembly. Maybe further we will go to the exploitation phase, which is covered for kernel exploitation and internal operating system and Win API, and yeah, a lot more of protection, SLR, DP, and more of that. No worries. For now, we just need to strong our foundation first, as I said before in curve learning. Learning curve, I'm sorry on that. If malware is in the form of .executable, okay, format executable that is converted from .bat, okay, how will process to analyze the malware? Okay, wait. I try to understand the question. So here you can same method. You can understand the format, the behavior from the executable is still it changed already from to executable format. So from there you can just decompile it and learn, deassembler it or decompile it and learn stuff there and understand how the behavior of the program and analyze the malware, right? I hope it's answering the question. If it's not, come back to me. Maybe there's a feedback form, or can just go to my LinkedIn, my link, and chat with me. I'm I will available there. All right. Okay. Um, we'll end at 9:46 or 47. So we have left question can be asked. Is there any question? I try to answer. One, two more, three more. Can just out of scope. Also, it's okay. I try to answer it. This is what we have covered so far. I hope this is foundation, basic stuff that if one go further and career development and learn more about reverse or money exploitation, and this is crucial to know lah in basics. What will be covered in part 2? Okay, let's go back to the table of content. We got 46 topics here. All right. Good question. Think on that. We end at compiling. So we already have covered 40 topics here. See? Yeah. 40 topics oops, already been covered here. So we will learn about next topic for part 2, the assembly and decompiler. Some overview of debugger that we will write program inside it, and we learn assembly inside it. Okay, and whole out labs. This you guys will learn, and this is all will be continue for the next section, right? Okay, there's some question. Where do you apply your reverse engineering skills? For example, job that relate to the skills. All right. Okay, let's go here. For now, I learning for myself first. It's just a hobby, because it's just a game for me. Like let's say there's some nothing to do. I just learn some things, and yeah, study is just like a game for me. If you learn more, you like level up, level up, level up. Yeah, that's apply it in myself first. I mean, you can apply it in yourself first, and what kind of job that relate to the skills. As I said before in the earlier, can be applied in if there is a job for reverse engineer, security research. You can code of virus, see the code of viruses, look for software vulnerabilities, and yeah, this is mandatory to know. This lesson should be a good foundation to you to before jump to this position. I believe. Right. I hope this answered the question. We'll share the slide and record it after all part finish. Yes. We will. I will share the slide in the end of the session. For now, after all part finish. Okay. Yes. After all part finish. All right. And the recording as well. Recording will be in YouTube. You can watch it. And yeah, I already contact organizer on that. All right. So you can watch it back. Like part first or part 1, part 2, part 3. Yeah. And for the next subtopic, it's like Win API, some protection, memory management, and the lot more. Yeah, maybe it's a series. The way it goes here to that want to empowering Malaysian education. Yeah. what I have, I share it. So we got, I can answer like one of two question here. So is there any question? I try to answer it. I hope you guys understand. Yeah. But sometimes my accent is not too good. I try. I try. Sometimes. Okay. All right. Welcome. Welcome. Nice. Thank you. Thank you. Thank you. Off topic, can malware or ransomware on a virtual machine infect the host computer? Yes, that's already in advanced level. Let's say the malware already customized in sandbox evasion. I mean, escape sandbox and is able to jump and apply their worms or something that can be infect from all hosts, pivot from one to any surrounding buildings, something. Yeah, it can. All right, it can. Depends on the malware capabilities on that. That's why we need to defend from it. Okay. That's already in advanced level. Yeah. Evasion, malware evasion, like if there is antivirus there and it able to detect, it's already have antivirus and EDR there, and yeah, depends on the malware. Right, that's already some advanced level already. Okay, I believe that's the last question from this part. Already 9:47. So we will end our session here for part one, right? I guess that's all. Thank you and for joining this class. All right. I hope you learned something here. Cheers.